So before we move away from looking for visual patterns of moisture, just under visual inspection, I just want to show you that. So this is the southeast corner right below the valley. And you can see that this is dry. And so the water management we've done with underground roofs and directing load away from those corners has been largely successful. And if we go over from here, here's the southwest corner. And again, it's dry. And you'll notice as we walked over here that we moved from a part of the basement slab that is leveled and stained, because we normally have a cloth divider here. So this is the finished portion of the basement, largely, roughly finished. And then this is just storage. But look what happens. We go from floor leveled and treated surface to some of the original concrete. And then this portion over here, right corresponding with that white mastic line, this portion of the basement concrete slab is quite new. And it's because this was just bare dirt. This is probably where they stored the coal back, when this first house was built. And they had a large coal bin in this corner as opposed to an oil fuel tank. But we're going to come back to this because these represent three different sort of stages of the basement slab, and particularly in terms of moisture management. But what I wanted to show you over here is that in addition to visual inspection, what's important is what can we measure. So when we're looking for moisture patterns inside a building, we're looking for two things. We're looking for what is the heat content and the moisture content of the air volumes, and then what are the moisture content of materials and what do they tell us. So I want to start off by saying that this is a hobo data logger, and it's measuring 79.57 degrees Fahrenheit and 61.6, just changed to 62.4% relative humidity. And so that's one of the ways that we measure the heat content and the moisture content of the air mass. And what I'm going to do now is show you that we can measure the moisture content of various materials in side buildings, including starting off with the wood. So what I'm going to do is show you that with a moisture meter, and we have two of them here. This is the Delmhorst BD2100, which measures moisture content by weight. There are two pins, and those pins, and this is all covered in material that you're reading as part of the background for this course as well. But electrical current goes between those two pins, and how much current moves through is proportional to how much moisture is in the wood. And through an algorithm table, you can find out what the percent moisture content is by weight. Now, this is another moisture meter called the QuickNav here, and I'm just going to show you that when I start this puppy up, I can go down to relative humidity and temperature. And this gauge at the top, which is a plug-in, and this is one of the things that makes the QuickNav different than the BD2100, is that this is recording temperature and relative humidity as well, but also converts those numbers into dew point, grains per pound of moisture, and even inches of mercury in terms of vapor pressure. But what we can see, if we hold this next to the gauge, is that they're reading fairly close. And so these gauges are probably plus or minus 1 to 2% relative humidity anyway, but they are tracking pretty closely if I can get both of those in. And that's an important thing to realize because it's not easy to measure relative humidity. And so the cheapo $10 ones you buy probably are plus or minus 10 to 15%, which is pretty much useless. So I always measure relative humidity and temperature with at least two devices to make sure I'm getting something that's actually representative. Now, going back to testing moisture content, you can see, and I'm mixing and matching moisture management and air control and thermal, but when I insulated this basement, because I had a lot of air leakage and there was no insulation, I did it with open cell closed foam. So you can see here the open cell closed foam. I built a 2x3 stud wall, put in replacement hopper windows. But when I built that stud wall out, that gives me insulation that's right up against these floor joists. Now these floor joists are let in to the concrete block, which means I have porous materials in direct contact with each other. And by insulating here, I've made the ends of the floor joists that go into the concrete very cold when it's wintertime. So if I make something colder, that means that if it gets wet, it's going to take a lot longer to dry. So I've shifted the hydrothermal balance, and what I'd like to know is, well, have I made the tail end of these floor joists cold enough that moisture rising through the capillary continuity of the concrete foundation to the concrete blocks of the wood, have I made them wetter over time? So, of course, what we can do, and I'm just going to show you here, if I start up the BD2100 and press both buttons at the same time, that's a calibration check, and it should read 12, which it did. And I'm going to just check and see what scale it's on. It's on 1 for wood. So I'm going to take and way back away from the ends that are in, and I'm going to do a moisture check. And so I'm getting 10.3. That went quiet pretty fast. 10.3 is the moisture content here. And then what I'd like to do is take it over, and that means that the only thing contributing to the moisture is just the moisture content of the air in that floor joist. So now I come over here and I take a reading here, and what I'm hoping is that it's going to be pretty similar, and you can see it's 9.8, which is actually a bit drier, 9.7, but it's close to this. Now, what I want to do is, again, at the end of March, when things have been cold and wet, and the coldest and wettest it's going to be, that's when I like to come back and compare the moisture content of the wood at the end that's closest to where it's moving into the concrete block, where it's not insulated and where it's in capillary contact with the concrete block in this case. That's the critical time to measure. Now, the last thing I want to let you know, and by the way, I can take this quick nav, and it's a more expensive gauge, but one thing I like about it is you can take pins of different lengths. You can see here, this is the little pins that are the same as the BD2100, but then I have two options here, this one and this one with different length pins. And that's basically extending the reach of the moisture meter. You can see that those pins are green coated. That's Teflon. That means that if they pass through wet material, they're insulated and they only read at their tip, which is an important aspect of extending the reach of the moisture meters. So I can plug the different length tips into this fitting of the quick nav, and I can measure the moisture content and heat content of the air with the attachment, and at the same time I can get moisture readings for materials. So if I know the relative humidity and temperature, I can, because the wood here absorbs and gives off moisture reflecting the moisture content of the air, I can check to see what's called the equivalent moisture content of the wood, which means that, you know, in a 2 to 3 week period, if the moisture conditions in the air aren't changing, the moisture content of the wood is going to reflect that, right? So it's important to be able to compare the moisture content of the air volume the wood is seeing if it's been steady over time, and notice that, you know, I'm running a high-performance dehumidifier, a Santa Fe Advance 100 down here, in part because when we built the basement, we only had a little bit of dampness in the walls and they were wet. So I put in vapor-permeable spray foam insulation, vapor-permeable gypsum wallboard, and vapor-permeable paint, because I'm letting these walls continue to dry to the inside. Well, what does that mean? When they're drying to the inside, I'm getting moisture both through the slab, if there's no capillary breaker moisture barrier underneath it, or through the walls. So it turns out that because I'm letting that moisture in, letting these concrete walls and the rest of the assembly dry to the interior, I have a moisture load, and particularly in the summer. So, but if this dehumidifier is set at a constant level, and it is set at 60%, and you can see that it's relatively close to that, it's reading 63, it's probably about to kick on. That means there's been a relatively constant moisture content of the air mass, and the wood should reflect that. So what does that mean? If I find wood that has moisture content above the equivalent moisture content, and by the way, in your resources, there's an online table from the Forest Products Lab, a calculator that you can use. But if you get moisture contents different than that equivalent moisture content, that is a pattern that means that something is wetter than it should be. So we've talked about how we can use moisture meters to measure the moisture content of wood. The Delmhorst meters, if I hit 1 is for wood, 2 I think is for concrete, 3 is for gypsum wallboard. So we can move among different materials. And if you look on the quick nav, you're going to see that it has for wood, drywall, and then scan. And scan is something we're going to talk about in just a minute in relationship to the moisture content of concrete.